Okay, so let's start and look at various 5G key technologies and various features so that you're aware broadly. And we'll be going into detail of these when we have a specific session on those topics. But let us be aware of all the key technologies. So let's start from uh, spectrum. So spectrum for 5G. So can you guess, and let us make it interactive also. So can you guess that which all spectrum 5G will be supporting? Any guess? You can use chat box to answer that what all spectrum 5G can support. So please use chat box, which frequency band or which spectrum 5G would be using. And okay, somebody says small cells. Okay, I'm talking about spectrum. Yes, answer about spectrum. Somebody says a millimeter wave. Somebody says 1 gigahertz to 6 gigahertz, 700 megahertz, and then so a lot of answer. So and all of you are correct, in fact. Okay, so basically 5G will support a spectrum which we call it uh, low band. So we call it low band. So all the frequency which is below 1 gigahertz, where there are various band for mobile communications. So these are supported in 5G. And then spectrum from 1 gigahertz, although it is written here 6 gigahertz, but in release 16 it has gone up to 7.125 gigahertz. So from 1 gigahertz to 7.125 gigahertz, the 5G will support various bands in this range also. And in millimeter wave also, uh, we have gone up to about 52 gigahertz up to release 16. And if you look at this picture, the lower side of the band will be for umbrella coverage, maybe for IoT rural area. The mid-band frequencies will be for macro and small cells and for capacity and coverage both. And the millimeter wave will be for small cell because higher the frequency, less the coverage. The cell size will be small, so we are calling that as a small cell, but the capacity would be very huge within that small cell. Okay, so as you can see in this picture also that lower side of the band will be for the rural coverage, mid band will be for capacity, and high band will be for very extreme capacity, that is the millimeter wave, that has been pictorially depicted. Okay, so there is also concept as in 3G and 4G, there is a concept of carrier aggregation. That means you can use more than one component carriers. So what kind of carriers can be aggregated? So the carriers in the same band, intra-band, contiguous. Suppose in a particular band, there are some chunk of component here, some chunk of component here. So it is possible that these carrier can be aggregated. Of course, you need support in your device as well as the infrastructure. Then even intra-band non-contiguous frequency can also be aggregated. So that means suppose in the same band, say frequency band A, you have some component carrier here, other is here. So this can also be aggregated. And even in if you have interband, like you have frequency band 1, frequency band 2, and frequency band 1, you have a small portion of frequency, frequency band 2. So this interband non-contiguous frequency band can also be aggregated. And as per the standard, 16 bands can be aggregated. Theoretically, 16 bands can be aggregated, but practically uh, that may not be use case because in your handset, how many antenna I can pack. So generally there will be a 4 antenna. So maybe 2, 3, 4 kind of spectrum can be carrier aggregated. But theoretically it can go up to 16. So if there are use case, they can actually go. The next concept is of bandwidth part. So what is bandwidth part? Even if for 5G will support a channel bandwidth of 400 megahertz, but you, I mean, the standard is designed in a way that you can use part of the bandwidth. So for example, if you are just accessing internet and you don't require a channel bandwidth of 4 megahertz, so you can use a smaller bandwidth part, right? So that you save on power, save on power consumption and electronics. And for IoT devices, which is required to operate only on low band, so you can design a IoT sensor with only low band, say 700 megahertz band, and a bandwidth part of 5 megahertz only, right? So that your complexity of IoT devices is less, cost of IoT devices is less. So there is a concept of bandwidth part which was not there up till 4G. In 4G, your device always operate on 20 megahertz, whether you are using or not, and that's why you consume a lot of power. So this is one of the way to reduce the power. So bandwidth part is to reduce UV power consumption or UV reduced bandwidth for IoT. And then there is a concept of numerology in 5G, which we will be talking about in our radio class. So it supports different numerology. It also can support non-contiguous spectrum, and it is for forward compatibility. So these are uh, various use cases. Somebody is asking me to talk about bandwidth part again. So let me give you an example. Your 4G phone supports 20 megahertz channel bandwidth, and it always operates on 20 megahertz, whether you are just doing internet browsing or downloading a movie or seeing a YouTube. Always the electronics used is
The
what
consumption for each separate user through
that part you can use the lesser part of the bandwidth to uh, reduce the power consumption and also to support IoT devices. Okay, let me go beyond. Then there is a concept of massive MIMO in 5G. So let me ask you the question: how do you, decide size of antenna in any wireless?
modulation.
How do you decide size of the antenna? Can somebody answer in the chat box? My question is, how do you decide size of antenna? How much size antenna should be? Yes, somebody answered wavelength. Yes, you're right. Very right. So as we discussed that 5G also support very high frequency. That means your wavelength will be in millimeter. So that means if you consider theoretically lambda by 2 size, so your antenna size will also be in millimeter. So that means in a small form factor of a panel like this, you can have thousands of antenna, more than 100 antenna or 1000 antenna. So you are able to pack very huge number of antenna in a small panel, and that's why name is coming as massive MIMO. So you'll have multiple users, greater capacity, and faster data. Now there is a concept of beam forming. So how a beam can be formed? Uh, uh, can you guess? So if you have studied radio, you might have studied that if you transmit same signal uh, uh, in suppose you are transmitting same signal onto antenna, so you'll have a very wide coverage, just like a bulb covers. But if you use two antenna and feed the same signal and you're keeping distance of lambda by 2, so your beam width will slightly decrease, right? It will not be 360 or 180. Suppose if you introduce more antenna, then you'll form a sharper beam, right? Sharper beam. So by increasing the number of antenna, we will be able to form beam, right? So and then you can cover more area and your spectral efficiency increases. So that is the concept of beam forming which has come into 5G. The another concept is of the steering of the beam. Suppose the car is moving, then the beam moves along with the car. So how to move the beam? So suppose you are able to create a beam. If you change phase of the signal in a way that your beam actually moves to a particular direction. So by continuously changing the beam depending upon where the car is moving, you'll be able to steer the beam. So that is called beam steering. So basically, massive MIMO and beam steering concept is designed for 5G, all because of having large number of antenna, and also now we have a lot of processing power on the back of antenna, which we are using to process and steer the beam. So this is a practical picture of massive. This is just you can count. It is 8 cross 8. This much size only you have a antenna, and then you can have one or more than one panel of antenna. So basically, the use of higher frequency band is allowing you to have a large number of antenna. There are many concepts. There are many concepts of SU MIMO, MU MIMO, single user MIMO, multi-user MIMO that we will cover in our class. Okay, so now as I was discussing that in 5G, all the network function is virtualized. So basically, up to 4G, whatever network function we used to have, that used to be a purpose-built hardware and software, which you have to buy from a particular vendor, say Nokia or Ericsson or any other vendor. But in 5G, these are software functions, right? You can write a code, anyone can follow the standard and write a code, and then it can be deployed either on a COT server or on a cloud infrastructure. So that is the change which has happened in 5G. So basically, it is disaggregation of hardware and software, enabling cloud native architecture. Uh, on any virtualized infrastructure you can deploy. So now we have very bigger and competitive ecosystem of the supplier of such infrastructure. A lot of innovation, even in India, has started happening because enabling environment which has come in 5G. The next, we had already talked about network slicing. So network slicing is nothing but logically dividing all part of your network into different piece, virtually different set of network element for different services. In this example, this is an autonomous car. For autonomous car or V2X, we have created a slice which may require low latency or which may require certain other quality of service requirement. So this network is built for that. Similarly, for a smartphone, you may create different slice where although less data, but you require a guaranteed data rate for voice, and you also need some low latency because you do not want any cut in voice, and also signaling has to be very robust. So a specific quality of service. And for smart metering, you have created a slice, right, which do not require large data volume. It is just requiring a deep coverage and a very small data. So a relaxed kind of a network. So you have created a slice for that. So you can create n number of slices, and one device can connect up to 8 slices as per the standard which is available today. Atul Kumar Jan has actually asked a question that whether normal servers or computes are being used. So answer is yes. Today even open source 5G core is available on the internet. Download, and on your PC you just create a partition, load a Ubuntu OS, and you can deploy on a virtual machine a 5G core. So that is a kind of innovation has happened. So although it will not give you that much capacity, but at least you can see how network functions are there. So yes, the answer is yes, Mr. Atul. Okay, now there is a concept of edge computing or multi-edge computing in 5G. So also we'll talk about in detail in upcoming class. This is just a some sort of highlight. In 5G, what has happened that we have disaggregated user plane part and control plane part, CP and PP. And since user plane is completely disaggregated, the user plane function can be installed near to the user, and all the application can also be hosted. Application can be of gaming, AR, VR, any other V2X service. So those will be near to the user, and that will enable low latency and local content to be delivered to the people there. So that's the concept of multi-edge computing. And then standard for multi-edge computing has come from C. So it is not 3GPP, it is an ITC standard. So 3GPP standard of 5G core and radio is designed in a way that it will be supporting the ITC multi-edge computing standard. Then we have a concept of Open RAN. So Open RAN is nothing but like earlier what used to happen that you have radio unit on top of the tower, and then you will connect that on a fiber to a baseband unit, base BBU we call it, on below the tower, and then this will get connected to the core network. So the interface here was proprietary. This software and hardware of BBU was proprietary, right? Like so, this interface was proprietary. So if you buy a equipment, you have to buy all the equipment from one vendor. That was kind of. So you were vendor lock kind of environment was happening. With Open RAN, this interface has been made open. This interface has been made open. This BBU has been disaggregated into software and hardware. Now you can deploy BBU software onto a COTS or generic hardware. So that's the Open RAN. So what they have done, they have divided this BBU into three parts. One, we call it remote radio unit. Second, we call it distributed unit. And third, we call it central unit. And interfaces between all three is made open. And then RRU is also a software deployed on a specific hardware. D is also software, can be deployed on any generic hardware. CU is also software, can be deployed on hardware. So anybody can build. So you can mix and match equipment from different vendor in an Open RAN. So that's the concept of Open RAN. In India, there are many companies like Lekha Wireless, VDN, and many small companies who have actually built Open RAN, and some of them are actually supplying in the US market. So that's the thing which has happened with 5G. As we discussed about 5G small cell, since we are using millimeter wave, our small size of the antenna is less, coverage would be less. So this kind of antenna, this is a vertical picture, small picture having large number of antenna would be deployed in every electrical pole, bus stand, all the street furniture that will be installed. And of course, you need to bring fiber or some kind of connectivity to small cell concept. So this is the concept of small cell 5G. We'll go into a bit detail in the later classes. For backhaul, there is a concept of radio backhaul also. So E-band. So E-band is range between 70 to 80 gigahertz. We call it E and B bands are there. So on E band, a lot of equipment has come which can give you up to 10 Gbps of a backhaul. So these base station would require backhaul. So either fiber backhaul or radio backhaul. So in radio also a lot of innovation has happened which can be actually used by the operator and by taking spectrum from the government. So the small, I mean, IAB I talked about, the small cell and integrated access and backhaul. So basically, as I said that this particular BTS where fiber has reached is not only serving the UV user equipment, but also giving a backhaul to the next base station. And this base station giving backhaul to the next base station. So this is the concept of IAB, integrated access and backhaul. So you can increase the coverage using this concept. So this is the architecture of integrated access backhaul, right? And you can also have a mobile backhaul in release 16. We talked about mobile backhaul, where is one of the node is here and it is taking backhaul from the previous base station, and you can create a coverage, temporary coverage in some area. So that's the concept. Side link, as I talked about, is like device to device communication on PC5 interface. So even if a particular device is not getting 5G coverage, but it can get coverage through other device which is nearby and having the coverage. And the use cases of this side link could be in public safety, IoT, etc. Just like these are mentioned here. We'll talk about these in the even other sessions. So there is a specific concept of quality of service. We have one full section on quality of service. So basically onto the radio, like from user equipment to G node, that is radio to UPF to the core, we have a concept of mapping those different data flow coming from different services and allocating specific resources. So we'll go into depth on the quality of service. We have a one full session on this. So there is a specific arrangement for managing quality of service, guaranteed bit rate, non-guaranteed bit rate, and all those parameters, reliability parameters. There is also a concept of dynamic spectrum sharing. That means the 5G can actually utilize the existing 4G spectrum in a dynamic way in every millisecond basis. So although we are not covering this topic in detail in this course, but recorded sessions are available. We will give you the link if you have interest. You can. And then in 5G, there is also concept as I talked on that in release 17. NTN integration is happening. So basically, your satellite can either work as a backhaul, or you can host some of the electronics. That means as some sort of repeater, it can work. So whatever signal 5G RAN has can be transmitted by satellite, or the entire T node to your RAN can be on satellite, and then we have a coverage of the satellite. So this is some sort of satellite integration we are talking about in week 17 and 18. I think we have 4 or 5 years to actually formally this system comes into picture. With this, even you can use your mobile in airplane or the sea when you're traveling onto the sea. And also you'll be using the satellite for delivering multicast and broadcast at edge. So basically, summary, it is for unserved and undeserved area, service continuity in planes or sea. For multicast and broadcast, the satellite integration will be very, very helpful. I just wanted to explain you what is standalone and non-standalone in 5G, because we talked a lot about it. So basically, you might have seen that Geo is calling as a true 5G, Airtel is calling it as a 5G plus. So basically, Geo has gone in a standalone mode, and Airtel is today it is an SA mode, but they will also migrate to SA very shortly. So what is SA? So what is NSA? Let us first talk about 4G network. So in a 4G network, you have a 4G core, you have 4G radio, and of course the PDN, packet data network. In 5G NSA, what you are doing, you are just adding 5G radio wherever you require more speed. You are adding 5G radio using the same 4G core and same packet network. So this is called 5G NSA architecture. This is called 5G NSA architecture. And what is SA then? Then the SA is when you have 5G core, you have the data network, and you have all the 5G radio. So those are called 5G standalone architecture. That's the major difference. Although we have lot many other options, which while covering the core we'll talk about. There is a concept of dual connectivity in 5G. That means whether you have a SA network or NSA network. So this example is the NSA network, and this example is of SA network. Your device, your 5G phone can connect to both 5G radio and the 4G radio in SA and NSA both mode. Just a moment. सर मैं क्लास में हूँ, मैं कॉल बैक करता हूँ सर आपको. Okay, so So if your device can connect to the both network and uh, have double the data, right? So you may be using LTE as well as NR. So you might have seen that nowadays even in 4G calling via Wi-Fi it comes. So that is the concept in 5G also. Here even the data will go through the Wi-Fi. There is a concept of non-3GPP access. That means even other than new radio, other non-3GPP access like Wi-Fi, etc., can also get connected to the 5G core. 5G core is called some sort of agnostic to the access, and you can connect even non-3GPP devices. We'll go into detail in 5G core classes. So typical 5G network will be combination of 4G network and 5G network. As I said, 4G and 5G will coexist for a very, very long time. So let me a little bit talk about 5G test bed, which was created in India, which our Prime Minister launched uh, in May last year, uh, 17th May 2022, which was so basically what is 5G test bed? It's a Indigenous created 5G complete end-to-end system where multi-institute like IIT Madras, IIT Mumbai, IIT Kanpur, IIC Bangalore, CIVIT and Samir together created this. So and this was completed in December 21. So basically, a lot of this is to enable our academia industry to create their own product, test use cases and other aspects. So basically, it is an enabling environment which has been created and it is available for everyone to use. So these were the different organizations working on different area of 5G. For example, IIT Mumbai worked on 5G core, IIT Delhi worked on some baseband algorithm, IIT Madras was on hardware platforms, and so on. So you can just read that. And all the efforts will to convert it into 5G testbed, which is hosted at IIT Chennai. So if you go to IIT Madras, you can see that testbed. So morning session, there was a question about EMF radiation health impact. So basically, radiation are of two types, ionizing and non-ionizing. So bad impact is coming from ionizing type of a radiation. So whatever spectrum we'll be using up to here, these all are non-ionizing. So even 5G or 6G, which we are talking about, is the non-ionizing spectrum. And as such, if you use wisely, there is no health hazard as such. Only the heating impact, if you talk for the longer time, you have a heating impact. So please be clear that as far as 5G or 6G is concerned, we don't have such a radiation impact, which morning somebody asked the question. So with this, perhaps we'll finish it today. I'll open